Right. Okay, good evening, everyone. It is my privilege to introduce our esteemed speaker for today's webinar, Dr. Shailesh Agrawal, sir. He is currently the Executive Director of the Building Material and Technology Promotion Council, BMTPC, under the Ministry of Housing and Urban Affairs, Government of India. Dr. Agrawal completed his PhD from the Department of Earthquake Engineering in IIT Roorkee in 2001. Masters of Science he completed from BITS Pilani in 1990. Masters in Technology in Structural Engineering from IISc Bangalore in 1988. And he completed his BTech in Civil Engineering from GB Pant University of Agriculture and Technology, Pantnagar in 1986. Dr. Agrawal is also visiting faculty member at the School of Planning and Architecture, New Delhi, co-teaching faculty at NIT Calicut, and a guest faculty at the National CPWD Academy. His contribution to the field have been widely recognized, and he has been felicitated by the Institution of Engineers for outstanding services to the nation in 2008, honored by Center of Excellence in Disaster Mitigation Management IIT Roorkee in 2010, recognized as an eminent engineer personality by the Institution of Engineers in 2012, awarded as an outstanding public officer in the CIDC Vishwakarma Awards in 2016, received the Lifetime Achievement Award from the Indian Concrete Institute in 2022, and many more. Dr. Agrawal has published around 100 research papers in reputed journals and conferences, authored over 5 books, and developed several dissemination and training series. Under his leadership, BMTPC is working towards the mandate of affordable housing for all through the Pradhan Mantri Awas Yojna, promoting emerging housing technologies, disaster mitigation, skill development, and capacity building. Dr. Agrawal is also actively involved in initiatives like the Global Housing Technology Challenges in India. Global Housing Technology Challenge in India. This is a brief introduction. Dr. Agrawal sir has a larger resume than this. So we could manage it to shorten it like this. We may have missed out many important points also. Sorry for that. You may take the floor now and give the presentation.
Yes. I think okay. I'm just quit and reopen. I have to reopen because I have to just join again.
Oh, sure, sir. Sure. We'll wait. Right, sir. Sir, आप audible नहीं है, sir. Maybe you're on mute right now. Sir, you're on mute.
I'm on mute.
Okay. Sir, now I have unmuted you. Your voice is audible, sir.
Audible?
Yeah, yes, sir. Yes, sir.
Okay. So thank you, Professor Ashwin, for inviting me to this structural steel education forum. And today I'm going to speak on, and thank you for such a nice introduction of mine. And I will be speaking today on emerging steel-based construction technologies for mass housing. But I would also like to take, am I audible?
Yes, sir. Yes, sir. Yes, sir.
And I'm also going to take you through the government initiative to bring, emerging construction systems in the construction sector. Government of India through Pradhan Mantri Awas Yojna is making concerted efforts to change the way we construct our buildings and infrastructure. So we conducted a global housing technology challenge, which I will be briefly touching upon, and through which we are trying to replace conventional, basically cast in situ RCC frame construction and load bearing construction by these new construction systems. And since this is a forum for structural steel, so there are few technologies which we are promoting, which are based on steel-based construction system. All of us know about this. If you look around the globe, you will find that there are two ways in which we do our construction. One is load-bearing structures, where we make masonry walls which are load-bearing, and then we put a cast in situ RCC slab. And slowly, almost everywhere nowadays, it is being replaced by RCC, cast in situ RCC frame construction. Particularly in India, we believe that frame construction is much better when it comes to earthquakes. So the most ubiquitous system around the globe, and in fact in India, is RCC, frame construction cast in situ. And earlier we used to have steel structures using hot rolled steel sections, but now with the manufacturing of built up sections, steel structures are also being preferred. Earlier the use of steel frame structures were limited to pre-engineered buildings or industrial buildings, warehouses and other things, but now it is being used even for residential sector. Also to make you, Ministry of Steel to enhance the use of steel in every sector of the country. Ministry of Steel has written to all the line ministries, and they have asked that use of steel should be enhanced, and therefore in construction also we are promoting steel based technologies. Okay, and which I will be showing you. The question comes to mind when we talk about age-old these techniques, load-bearing structures and framed structures. The question comes to mind why we want to replace these systems by new, innovative, alternate, or emerging construction systems. All of us know speed is the key. I have been telling this in all the forums that in times to come, in addition to cost, how fast you can construct or deliver your project will be one of the deciding factor when we decide about the process, materials and technologies of a particular project. So speed is one of the criteria, and that is why we call these technologies fast track construction technologies, which can expedite the construction or reduce the construction time. Quality, all of us know when we do cast in situ construction, the way quality is being compromised, it's no longer a secret. And being in earthquake department, all of us, whatever we do, it has to be safe. And one of the top priority which is to be given whenever we undertake a project or build a structure or building is safety with respect to natural hazards. Okay, and sustainability is also a new thing which is now has become very pertinent as civil engineers, architects. We have to think in terms of energy efficiency, environment friendliness, net zero, then greenhouse gas emissions. So sustainability is another important thing which we need to consider when we talk about construction. Life cycle costs. Again, any project or any building, when we see, we always ask what is the cost, and that cost is nothing but initial cost of construction. But there are other costs also involved when we talk about any structure. The other cost which is involved is operation cost or maintenance cost of a building. Once your structure is ready, during the service life of building, a certain amount of cost is required for operating that building or for maintaining that building. So that cost is called operating cost or a maintenance cost. And then once the service life of building is over, how you are going to demolish and dispose that building so that there are no adverse effect to the environment. That is called demolition cost. So the total cost of any structure which we build is initial cost of construction, which you call cost, plus operation cost or maintenance cost, plus the disposal cost. And these three added together constitute life cycle cost. So our aim should be to minimize life cycle cost. And there are studies, and you can find out yourself that within 20 to 30 years of the service life of building, the operation cost to become more than your initial cost of construction. Then the last but not the least is thermal acoustics and functionality of the building. So whenever we talk about new technologies, we are not only talking about structural soundness or structural integrity, but we are talking about functionality of that building also. In no way the functionality of building can be compromised when we introduce these new technologies. Okay, so emerging construction technologies or systems or processes will bring speed, will help in constructing quality structures, safety, sustainability, life cycle cost, and at the same time functionality. Also, there have been a number of studies, and this particular study was done by the Energy Research Institute, which says that sustainable buildings can significantly reduce the energy use, the water use, and greenhouse gas emission, and 75% reduction in waste. Again, a very interesting slide which I wanted to show you. This slide shows the level of construction technologies. And if you just closely look at this slide, you will find that when construction comes to our mind, we always think of level 0. Most of the construction is which we do is level 0. That means, you get the material at the site, hire the contractor, get the formwork, put the reinforcement, do the concreting, remove the formwork, and do the finishing and all. So that's the most popular or the most prevalent level which is being practiced when we do construction. Level 1 is pre-engineered buildings. All of us know how industrial structures, warehouses, industrial sheds are being constructed nowadays. You have steel beam columns and steel trusses which are manufactured somewhere off-site or in the factory and then brought to the site, assembled at site, trusses and all. You put the roof coverings and your industrial shed is ready. That is level 1. Level 2 is prefabricated or precast concrete construction, where instead of making beam columns, any structural or non-structural element at site, make them off-site or make them under control condition in the casting yard or in the factory, and manufacture these components there, transport them to the site, assemble them at the site, and your building is ready. That is level 2. Level 3 is another level up, where instead of making these planar elements, your wall, beams, columns, staircase slab, the sunshades and all, instead of that, you make the entire module. So the entire module or entire room comprising of 4 walls and a slab or a floor in the casting yard or factory, and then transport it to the site, and put them one over the other, to create your multi-story stack or your building. And it is like, a simile which I should give here is like Lego blocks. As a kid, we play with building blocks, and building blocks are put one over the other to create a building. In a similar way, you can just create these modules and just put you can just put them one over the other to create your multi-story. Level 4 is another level above, where you do the finishing also in the casting yard or at a control condition or in a factory. Okay, so 80% of building work, which includes your finishing, which includes your putting your services, the bath, kitchen, and other things, tiles and other things, windows and doors. Up to 80% of work is done off-site and then transported to the site, and on the already laid foundation, you just put that structure and start using it. That is level 4. And this level 4 is also, there are companies who are calling it plug and play homes. So it's like plug and play homes, like your USB drive. You just get this entire structure made, transported to the site, connected with the services, which is your water, electricity, and sanitation, and start using this. And our effort, at Government of India, Ministry of Housing and Urban Affairs, through Pradhan Mantri Awas Yojna, we are trying to take a paradigm shift from level 0 to level 3 and level 4. Let's introduce these level 3 and level 4 in the country, and transform the sector by introducing these cutting-edge, fast-track construction technologies. And the good news is already these labels exist in our countries. There are capacities available. There are engineers and architects available who are doing these kind of things. Also, there are enough technology providers and executors which are using these technologies in our country. Also, we at Ministry of Housing and Urban Affairs have proactively demonstrated these technologies, these construction systems across the country, which I'll be showing you through lighthouse projects. And our sincere effort is to popularize, to create awareness amongst professionals, sensitize them, and adapt these technologies as future technologies for the country. So through this slide, let's take a pole vault jump from level 0 to level 3 and level 4. And there is no need for me to tell you the advantages or merits once we take a leap from level 0 to level 3 or level 4. Okay, and all these things are also ensured. Now, since it is on steel, all of you might be quite familiar if you are regularly joining this structural steel forum. This is the global per capita consumption of steel per annum, and as you can see, India now I think it is 90 kg per annum. When this slide was made, it was 74, and this is from Ministry of Steel website, whereas global average is 2 to 5. And dear friends and students, the most developed countries in the world, they have, steel is something which drives the economy, and the most developed nations in the world have, maximum steel consumption. As you can see here, 590 China, Japan 514, and we are still around 100. And if we talk about construction infrastructure sector, the consumption per kg is 50, and you can see from this slide, China is far ahead at around 8 times above than our consumption of steel. And that is why I told you in the beginning that Ministry of Steel has very aggressively pushing use of steel in every sector. And therefore in Ministry of Housing and Urban Affairs also, because we are running a scheme called Pradhan Mantri Awas Yojna, through which we are pushing the use of steel in buildings as well. Whenever we talk about steel construction, all of you are aware, very familiar questions being asked, and I have just put them here. Higher initial cost, everybody says that steel is expensive, but with the availability of built-up sections nowadays, steel sections replacing frame construction may come out to be cheaper. And I just tried to put some points. Higher initial cost, steel construction may incur higher initial cost as compared to conventional building, but if you do high rise and all, the cost, additional upfront cost gets decreased. And commercial buildings nowadays, as you know, most of the commercial buildings are made, all malls, all structures are being constructed using steel sections. And now in residential sector also, the steel structural sections are being introduced. Okay, I have another slide where I will show you, actually there have been few studies which says initial cost, the percentage difference between initial cost and time. Low life cycle cost, we at Government of India are promoting now life cycle cost. If a project size is bigger, always think of life cycle cost, because life cycle cost will give you an idea of environment cost also, and sustainability also. So when we talk about steel construction, the life cycle cost is always low, because the repair and maintenance cost as compared to conventional system is much less. Salvage value, all of us know structural steel used in a steel intensive building is 100% recyclable, whereas that is not the case with conventional buildings. So let me just give you again, this is from the most authentic source from Ministry of Steel website. You can see, depending upon the floor, the additional initial cost is just 11 to 20%. For low-rise structures, 0 to 4 floors, mid-rise 18 to 14, and when you go high-rise, the additional cost is 4 to. So that is initial cost, but life cycle cost is low, salvage value is there, and there are better, disaster resistance or seismic resistance. And when we talk about commercial buildings, the percentage is this. And at the same time, if you look at the construction time, you will find up to 20% time, 20% construction time can be saved. That way, the steel construction, steel-based technologies are much more useful when we think of buildings and infrastructure. Okay, environment friendly, steel being recyclable, and quicker construction time, and 30 to 40% lower concrete requirement. And when you are using less concrete, that means use of water is reduced, use of sand is reduced, so resource efficiency. So whenever we talk about green buildings, or whenever we talk about sustainability, we talk about there are, in addition to energy efficiency, eco-friendliness, we talk about resource efficiency, how optimally you are using your basic materials, which is steel, cement, and sand, and all these things, because they are based on finite natural resources. So resource efficiency is also of paramount importance. Also, when we use steel structures, air pollution as compared to conventional one is less, dust and all is minimized, waste is also minimized. Steel construction also offers a clean construction, and it can be carried out in congested areas, resulting in reduced public nuisance. Okay, and durability. If we talk about life of a building, normally a concrete structure is lasts up to 70 years, whereas the steel construction, the life is 100 years. Okay, so higher durability. So because of these inherent advantages, initial cost is high but low life cycle cost, higher salvage value, less construction time, environment friendly, being recyclable, clean technology because there is no dust, and no waste, and durability is high. Because of all these things, steel construction is a better proposition. High carpet area, because in steel you have a thinner sections, and you can have thinner walls. So for the same built up area you will have more carpet area. Disaster resilience, I don't need to explain you this. Steel buildings are better for highly seismic zones, and all of us know that in our country we are being faced by earthquakes recurrently, and any area earthquake can come. So we have to build safer structures which are hazard resistant. Construction need to be done. Flexibility, steel construction offers great flexibility. Also, you can do reconstruction and renovation is easier. So these are the advantage of steel construction. And what we did, we at BMTPC, we in 2018. We started looking across the globe that what are the emerging trends in housing construction. So we found that there are several systems which can be transplanted to our country, adapted, and can be adapted to in our country. Because of the advantages which I just explained you, speed, quality, life cycle costs, and other things. And I will just explain you these systems. So we have just given the nomenclature. This is the nomenclature given by us, but you can call them by any other name. So these are engineered formwork system, stay in place or lost formwork system, sandwich panel system, or drywall construction system. And you can see in this emerging trends in housing construction, there are two steel-based technologies. One is light gauge steel structural system, and another one is steel structural system. And the other category is precast concrete construction system. So engineered formwork system is nothing but aluminum formwork. All of you know about I1. So here you have customized formwork. Instead of having formwork for beam and column, you have the formwork for the entire module, which is of aluminum. And nowadays steel formwork, it is called tunnel formwork. I'll show you a picture which is of steel that can also be used. And instead of making all the the modular structure, you just make the structure in form of a tunnel, and the short walls are infill walls. Okay, and stay in place the lost formwork system, where we have stay in place formwork system which can act as a part of the structure. Formwork basically is removed once the structure is ready, but sometimes when it is left in the structure to be the part of the structure, then it is called loss formwork or sacrificial formwork. And there are two kinds of formwork, which, if it acts as an insulation, then it is called insulating concrete formwork. And if it acts as a part of structure and help in, fracture and other resistance, then it is called structural formwork. Then sandwich panel systems are drywall construction, steel structures, all of you. And as I have been telling you that there are already these systems exist in our country. There are enough technology providers and agencies available who are doing these kind of work. All of you know about 3D printing. 3D printing is one of the upcoming technology, and this was the first 3D printed house in our country, which was done by L&T in Kachipuram. You might have heard. I will just play this film for you if I can. Let me just see. Yeah. So this is the first post office building which was printed in Bangla, and it was in 2023. So we have this kind of model, and application being controlled through a tab, through a laptop. There's 1,000 square feet for controlling. Just see its additive manufacturing or there by their construction.
USP is the speed. USP, if you want to bring this shape, it is not easy. With a 3D printer, any shape is possible. It's all controlled by laptop. Everything is controlled. You feed the drawing to the laptop, and it does the heavy.
And then, so 1,000 square feet, it was built in 45 days and 23. Okay. And yeah, it was like 100 years. And when this post office was inaugurated by Honorable Prime Minister, and inaugurated this post office, Honorable Prime Minister did say that every Indian should feel proud that we have indigenously printed our first the post office. Okay, and there are several studies like this. This is again, this was shot by me. This is the Air Force, in Chandigarh Air Force Station. The entire township, a small township, is being done with 3D printing. And what you find here, I will just play this as well for you. There is no sound here. So what you see, this is a gantry printer, and you see a gentleman here in a yellow jacket. He is holding a tab through which he is controlling the operations. Okay. So there are what I want to make you believe is that these kind of things, there are already successful case studies in our country. Now let me tell you something that we pass. 96 dwelling units in S plus steel plus 1 configuration was completed in 96 days and given to the benefit. And this project was a SIPCO in Namibia. So steel plus 12 floors, and the technology used by 3 class computer. So just adjacent to the slide, they set up CSIR, the all building components, structural manufacturers. The structure was advanced, and then three power things were lifted and assembled. This is a kind of video you can see. In 3 days, one floor was. In 3 days of one complete floor was made. This is a typical casting yard, and where all the elements have been. Very few elements. These are 3D model. We have charged for 15 jobs. We are being charged, and
And this is a facade or a wall with all the architectural creation. See, so this is a partially precast with bubble wrap, which will be put and then the steel control will be put. They told you the mission was complete 96 journey units and 96. Maybe it's cost you sometimes 20 is 25 in person. This is a BIM model. So you can see here 6 April 2022 and right way all these 12 trades were you know, finishing work is going on. Finishing the staff. The project was executed by LNT and there are two other agencies, BBPT and NCL. We are also doing the project here and appealing the funding. So this is your finished product. Both to sell everything and the fees are given to the benefit. And we try to fix and the fix it. I said it.
Now let me also show you this. This is based on steel. So in earlier video which I showed you, that was on the RCC. That was precast concrete construction. Then again in 2023, again there was a news item that DRDO constructed a flight control system complex in Bangalore. In 45 days, the built-up area was 1.2 lakh square feet, and here they have used, it's a hybrid structure where columns and beams are of steel and other things are of concrete. So I'll just play this for you also to show you the efficacy of steel structure system.
We have built 7-story buildings in 45 years. Again, this building that we have good minister. And whenever we talk about these technologies, you can see that we get these steel columns and the foundations come down. So you in the foundation, in the plinth, with the double wrap and then these are the steel columns and steel. So it's a hybrid structure. Staircase and other things are assembly. Everything was done outside, got to the side, assembled at the side, the side is the glass was on the glass, everything.
So these videos, your participants, I just wanted to play for you to make you believe that these things are already happening in our country, and we are just trying to bring this so that these technologies become future technologies in the country. I will just skip this, but during another very interesting thing, during COVID time, there were a lot of news items that China, Russia, they have built hospitals within no time. And we were also asked that do we have these kind of technologies? Then I still remember that I said yes, we can do it with the steel, light gauge steel structures, or this steel sections, hot rolled steel sections, or built up sections. And later I we found that the number of COVID isolation wards were created by number of Indian agencies across the country using steel structures within no time. And this I will escape, but there is a South-based company called PMAY. They constructed a hospital in 2023, and it appeared in Guinness, Limca Book of Records using precast technologies. The three-story building was constructed by PMAY using precast concrete. So I'll just not run it for you. Also, all these things are available on our YouTube channel. So in case you want to know more about these technologies, you can go to my YouTube channel. Just type my name or type BMTPC and you will get access to lectures, presentations. Now let me come to steel structure system. Because as I showed you in this, there are, these are the broad categories in which we have shortlisted the emerging construction system and which we are promoting, and we are making sincere efforts, concerted efforts to make these technologies future technologies of India. But since today we are talking about steel, so as I told you, we have light gauge and steel structure system. So there are three categories which I will be explaining you today. So if we talk about steel structural system, one is monolithic concrete construction system, stay in place formwork system, and steel structural system, hot rolled or built up sections, and light gauge steel structural system. So this is the most popular or most widely used technology right now in our country. And just to make you understand, so conventionally what we have this kind of structures. We have formwork, beam, column, slab, and then we do the construction in the conventional way. But nowadays, instead of having separate formwork, you have an aluminum formwork, and for the entire modular unit, you get the customized aluminum formwork, and then do the casting in a single pour, remove the formwork, take it to the next pour. And this is of aluminum, but nowadays steel, customized steel formwork systems are also available. You might have heard of slip formwork or jump formwork or table formwork. There is one formwork called tunnel formwork, and we have used this. So instead of having formwork for all the four walls, you have, again, it is a customized formwork for longer walls. And why it is called tunnel formwork? Because you create a tunnel kind of structure. Okay, and this is made of steel. It is inverted L. So you put this L and then slab and walls are cast together to create a tunnel kind of thing. Okay. Then there is another is structural stay in place. So as I told you, these are lost formwork system or sacrificial formwork system. Again, these are the panels which are made in the factory. This is a galvanized iron, and there are stiffeners. You can put steel bars as well. So these panels, again, customized, made, and these panels can be used as load-bearing panels. So you erect these panels and then put the concrete, and depending upon your geoclimatic profile, hazard profile, and the number of stories you are constructing or building, you can put the reinforcement and do these things. So the idea here is replacing your classical or conventional brick wall by this customized formwork. So there is a company called Coffer, and all these technologies are branded, come with a specific name, come with the name of the company. So generalized name is stay in place formwork system, but this particular system is called Coffer system. Then, as I told you in the beginning, that nowadays with the advent of built-up sections, you can have frame construction, cast in situ frame construction replaced by, built-up steel built-up sections of beam and columns. And we are also promoting this for residential sector as well. Okay. So there are a number of companies. There is one company based on Chandigarh. They have a technology and they call them Insta Home. Insta Home means instant homes. So they will provide you the entire, as per your requirement, they will provide you beam, column, cut to the sizes, and you can have them. So this is how it looks like. Entire thing is done under the CAD thing, and this is how it looks like. So everything is done beforehand, and all the components are being supplied. So you can have a deck slab of this kind. So the another flexibility with the steel is you can have any kind of thing. So you can have a steel beam column, you can have RCC slab or RCC floor, or you can have a deck slab, or you can have any other kind of slab. And similarly, you can have brick masonry wall or any other kind of wall, or you can have a sandwich wall as well, sandwich panel wall. This I always show in my presentation. In 2014, what you see this structure, this is a 10-story mall which was built in Mohali. Mohali is in outskirts of Chandigarh, and this was constructed or erected in 48 hours. And in 2030, and that time the entire operation was seen by the then Home Minister. So 10-story mall was constructed in 48 hours, and the technology used was this steel. So steel beam columns, and then these walls are sandwich panel systems. Also, after Hudud cyclone, I was asked to give the technology. The Andhra Pradesh government wanted to quickly rehabilitate the Hudud victims, so we conducted, a tender. We started searching the technology, and ultimately we found that steel structural section will be the most viable solution, and that was the technology given. And steel beam columns, and then the deck slab, and the walls are AEC panel. Then this is about structural steel section. Then nowadays another technology which is emerging and which has huge potential is light gauge steel or cold form steel. Cold form steel, all of us know about it, but it's nothing but what you do is galvanized steel strips of steel are fed into a roll forming machine to create these kind of sections, and it is called light gauge steel because these sections are thin, and any kind of section, U section, Z section, or box section, any kind of section you can get, and with these sections you create customized wall panels, and which can be erected. With being light in weight, it has good seismic resistance as well, and we have recommended this technology only up to 4-story G+3, but if you go to foreign countries, you will find this technology being used for high rise up to 10 stories as well. Hong Kong, Singapore, and all. But here in our country, we have recommended this up to 4-story, and this is a good technology which can be used for low-rise structures. So you can see this. So these are the light gauge wall panels which are customized, and as per your requirement, as per your project size, and plan and elevations, these panels are supplied to you, and you can just put them side one over the other and side by side to create the wall, and both the sides of walls are then fixed with calcium silicate board or fiber cement board or precast concrete panel. I think I have a slide. Yeah, so you can see here. So this is how it looks like, and I think I have a slide. Yeah, and entire thing can be modeled. I am not going into that. Entire thing can be modeled in CAD. Also, we have an Indian standard also. And when we talk about steel, there is a whole lot of flexibility here. I'm trying to show you steel structural sections for beam and column, and these walls are light gauge steel walls. Okay. And when you do the construction using these light gauge panels, as I told you, the foundation is conventional. So you come at the plinth level, and at the plinth you put a channel, and then you erect these wall panels. Okay, and everything can be done quite easily by few persons at the site with the screws and all. You put a channel, then you put these panels, and then encase them with the fiber cement board or precast concrete. Yeah, what you see here, this is that fiber cement board which you put from both the sides, and the in between space, hollow space, can be filled with rock wool and all. Rock wool, or it can be filled with lightweight concrete as well. So this is you can see this is the finished. This is the township of Jindal Steel in Raigad. Just it is in near Raipur. They have a steel plant, and there they have created light gauge steel, light gauge structures for their employees, and you just can't make out seeing this that what they are made of. Okay, and there are different kinds of volume options for LGSF. As I told you, you can have fiber cement board, you can have EPS panel, you can have precast concrete panel. So here we are replacing the conventional, your brick masonry wall in English or Flemish wall by these kind of. There are variety of fiber cement boards and sandwich panels available, which can be used for variety of applications, load bearing as well as non-load bearing. Okay. So again, the life of a building is 50 to 60 years, and construction can be completed within 4 to 6 months time with proper planning and arrangement when you are using these sandwich panel systems. Okay. And as I told you, for steel structure, for light gauge, there is already we have a code IS 800. All of us are aware of, and there is another code IS 801, which was reaffirmed in 2010. So this code can readily be used to design and construct light gauge steel structural systems. Okay, and also whatever technologies I talked to you, all these technologies have been included by CPWD in their Delhi Schedule of Rate. And recently they have come out with the Delhi Schedule of Rate of 2023. So you will find a separate chapter which talks about Schedule of Rate of all these new technologies. Okay. And just to give you the few things that during COVID, LGSF has been used as potential technologies for construction facilities. Kerala government has already shortlisted this for constructing houses under Life Mission. Okay. Then, in 2019, we conducted a global housing technology challenge where we wanted to, look around the globe and wanted to study, evaluate, and bring global construction systems which can help build maximum number of houses in minimum time in our country. So through that challenge, we shortlisted 54 new technologies, which were divided into those 6 categories, which I showed you in the beginning. This challenge was, conducted, and exposition, huge, exhibition exposition was organized in 2019, which was inaugurated by Honorable Prime Minister, and where all global players were asked to display their construction systems. And then we constituted a group. I think IIT Roorkee was also part of it. IIT Roorkee, CBRI, and other public and private agencies with GGCPWD as its chairman. So through that, we studied all the technologies and shortlisted 54 new technologies. So details of these technologies, you can just note down this website. You can get the details of all these technologies on this website. And as you can see, there is one category which is based on steel, which is light gauge steel structural system and engineered steel structural system. Okay, and then having shortlisted these technologies, we thought that we should demonstrate also these by actual field level implementation. So again, we conducted a state level challenge, and under Pradhan Mantri Awas Yojna, through these 6 categories, we executed 6 lighthouse projects, and we called these projects as the lighthouse projects, and use them as live laboratories so as to understand, learn, and adapt these technologies for future construction. Okay, and you can see there, these are the 6 places: Indore, Rajkot, Tamil Nadu, Chennai, Ranchi, Agartala, and Lucknow. And out of these 6, there are 3 projects which are using steel structural system. Hybrid construction. Indore, we are using steel structural system. In Rajkot, we are using tunnel form, which I will be showing you. And Agartala, again, steel structural system with light gauge panel. And in Lucknow, also steel structural system with, infill walls of different kinds, sandwich panel system. Okay, so we thought of showcasing these technologies through field level application, and I will just show you those. These lighthouse projects, after shortlisting these emerging construction systems, from COVID came, and after COVID in 2021, the foundation stone for all these 6 lighthouse projects were laid by Honorable Prime Minister, and then right now all the projects are completed except the project in Agartala, and already beneficiaries are living in these lighthouse projects. So Chennai is using precast. I will not go into detail, this is a project which is finished. So it's a 6-story structure. We are just adjacent to the site. Casting yard was set up, and in that casting yard, all elements were cast and then brought to the site to create structural skeleton, structural system, then partially precast slab, and the walls are of AAC blocks. Okay, so this project on 26th May 2022, the project was completed and handed over to them. In Rajkot, we have used this. If you look at the bottom right hand side, you will find this is the tunnel form I was talking about. So it's an inverted L made up of steel. So these are customized tunnel forms as per your project, and you just get them and then erect them, put the reinforcement, do the casting to create a tunnel kind of structure. And this is a 14-story structure, and the skeleton of this structure was constructed in 50 days. So just one tower in 50 days, the skeleton of it, because of this tunnel form. So this is the kind of speed, or this is the kind of speed you can attain using these technologies. So again, this customized from Rajkot, and there is a company, this is a Switzerland-based technology. This was brought to the site from these tunnel forms were manufactured in Pune and then brought to the site. So it is an inverted L kind of thing, and then they are put like this with reinforcement and services and everything, and then concrete is poured, and then form work is removed and taken to the next story. So this is the tunnel form I'm talking about. Okay, this project was also inaugurated by Honorable Prime Minister, and this is that steel I was talking about. So hybrid construction in Lighthouse Projects Indore. Again, it's a high-rise S+8 structure. Hello. Ashwin. Hello. Hello. Acha. Okay. Okay. Now it is coming. Is it coming now? I'll just. Okay. Let me just see. Okay.
The slides are visible now, sir.
Okay, so slides are visible. Shall
Yes.
I? Okay, sorry.
Yeah, no problems.
Yeah, it's coming now.
Yes, sir, it's coming.
No,
It's coming.
So shall I go to okay? So you tunnel form you could.
Yes,
Yeah, it's okay.
yes, sir. From
So shall
Rajkot.
I read tunnel form again?
नहीं सर, राजकोट का ये स्लाइड से आप स्टार्ट करिएगा सर.
Okay, so Rajkot. Okay, so I'm sorry for the goof up. So the Rajkot project we are using with that tunnel form. So these tunnel form are inverted L, which are of steel, and there is a Switzerland-based company. They are based in Pune, and they have their manufacturing plant in Pune. So there they supplied this tunnel form, and as I told you, this is a customized tunnel form which is supplied based on your project requirement. Okay, and then you put these what you see in slide number 2 here, that you put these inverted L to create a tunnel kind of thing, insert the reinforcement, put the services, do the concreting in a single pour, and then remove the tunnel form and take it to the next row. And that way you can create the entire structure. And as I was telling you, this 13-story skeleton of this structure was erected in less than 50 days under Pradhan Mantri Awas Yojna, using this tunnel form. Again, the project was completed and handed over to the beneficiaries. Now let me show you this Indore. In Indore, we have used hybrid construction, and it's a 9-story structure, steel +8. And here we have used, these are built up sections. And I think most of you know, earlier we used to have rolled I sections and all. There is no need to roll out the I section. You can just, weld 3 plates to create an I. And that way you can save on material, and there is flexibility also. So we have used built up sections for beam and columns here, and your floors are deck slab. Deck slab means you have a profile sheet. Over that profile sheet, you put a nominal reinforcement and then put a 75 mm speed over it. So this is that hybrid structure I was talking about, which has been used in Indore. The project is already, handed over to beneficiaries, inaugurated by Honorable Prime Minister. So you can see here, this project is in Indore. So there was a, this steel sections were supplied from 2 locations, one from Indore, and I think another one is from Pune or somewhere. And then you erect them, and you have a deck slab, and then these infill walls are that sandwich panel system I was talking about. Okay. Then let's move to the Lucknow project. Again, here also, since it's a 14-story structure, here again we have used steel, built up steel sections for beam and columns, and floors are deck floors, deck slab, and the walls are stay-in-place sandwich panel system. This is called stay-in-place formwork. These are pre-finished walls. Any other time, if you give me time, then I will explain you other technologies also. So there is no need to create a wall. As I told you, you have a sandwich panel system. So in that category, there is a technology which is called pre-finished walls. So you can just buy those walls and do it in a do-it-yourself kind of thing. You can just erect those walls. Okay, so they come in a size of width 2 feet width, and you have as per your height, they will produce those wall panels as per the height of your room, and they come with slide and lock arrangement or tongue and groove arrangement. So you just put those walls one side by side to create the entire wall like this. Okay, so here we have used hybrid construction. Beam and columns are of built up steel sections, and we have deck slab over which we put a screed concrete with nominal reinforcement, and walls are those pre-finished PVC wall forms. This was also handed over to the beneficiaries. Ranchi, again, government project. Here we have used that I was talking to you about level 3, where you make, instead of making beam, column, wall, facades separately, you make the entire module. So it is called 3D volumetric construction, where you are making the entire module in the casting yard under control condition, and then putting them one over the other to create your building. So it's a 9-story building, and where just adjacent to the site, they had the company, the agencies had set up the casting yard where these modules were cast and then put one over the other to create this structure. So you can see here, so this is that casting yard where all the elements were cast, and then on the already laid conventional foundation, foundation used here was raft, and over this, these modules were just put one over the other to create the building. Okay, and the last one is Agartala. Unfortunately, this project is not over. Still work is going on because of difficult terrain and difficult site conditions. Here we have used light gauge wall panels. So since Agartala falls in CSB Zone 5, so and it's a 7-story structure, and light gauge we have recommended only a 4-story. So what we did, we replaced light gauge, beam and columns, instead of having load-bearing light gauge walls, we have used them as a infill walls, and your structural system is steel, built up steel beams and columns. And again, here to encase these light gauge panels, we have used precast concrete panels. Okay, and floor here is again a deck slab. So now these light gauge panels are being manufactured at the site itself. They have got the roller forming machine at the site, and with the galvanized steel sheets, they are producing these wall panels there at the site, and then doing the construction. And here, the space in between is being filled with lightweight concrete. See this. In addition to lighthouse projects, we have been entrusted by Government of India under Pradhan Mantri Awas Yojna to execute demonstration housing projects just to showcase and spread awareness about these technologies across the country. So we have been doing a number of projects. I will just show you the projects which we are doing with the steel-based technology. So this is the project which we did in Hyderabad, and we roped in IIT Hyderabad to study, evaluate this project, and organize training programs. So IIT Hyderabad conducted a detailed training programs and also studied this project. So it's a complete project with light gauge. So it's a load-bearing structure, G+2 3-story structure, where we have used you can see there are two buildings here. In one, we have showed light gauge steel frames, and this is that I was talking to you about structural stay in place. So these are galvanized, wall panels which can be used in load bearing. Which can be used as load bearing panels. So these panels were, manufactured in the factory, brought to the site, and just erected in a load bearing fashion, and then concreting was done to create this load bearing structure. So in Hyderabad, already this project is over. This construction was done in one of the building center, and this is being used as a training hostel. So two technologies are demonstrated here. One is light gauge, and another one is structural stay in place. Another one in Bihar, Bihar Sharif, it is being used as a sports hostel. Again, G+2 here. Again, we have used that stay in place formwork system. Then this is the project in Haryana, where working women hostel was created by us. As you can see here, again steel structural site, light gauge steel structural framing has been used. And what you see here, these are the staircase wells where we have used built up sections of steel, hot rolled steel. Okay, this project is also over. Then in Agartala, again we made a old age hospital. This is already in operational. Here again we have used this, stay in place formwork system. Then in Ayodhya we are making, ashram for destitutes and widows. You can see here the community center and the hostel. Everything is being done with the light gauge steel structure system. These are the ongoing projects, as you can see here. These are completed projects which I showed you. These are the ongoing projects. So if you want, you can go and see these projects. In Jammu, we are using, expanded sandwich panel system. In Dimapur, we are using again it's a steel structural system with the sandwich panel system, and then in Guwahati also we are using steel and light gauge steel structural system. Okay, and that is all I wanted to tell you. Also, we are working in close coordination with all the state governments, and as I told you in the beginning, our aim is to make these technologies as the future technologies of construction for the country. And just to create two lines that what happens being in government, sometimes we are, we require sort of certification and other things. So all these technologies have already been certified by the Building Materials and Technology Promotion Council, that is my organization, because we are mandated or authorized by Government of India to do so. That is one thing. Secondly, since CPWD is also in our ministry, for all these technologies, schedule of rate has already been brought out by CPWD, and you can just download their Delhi schedule of rates, and you will find a schedule of rate for all these technologies. And thirdly, CPWD has already has already come out with a circular mandating use of these technologies in their future projects. So that circular also you can see. Also, Ministry of Housing and Urban Affairs, they have also issued several notifications where they have some, given where they have notified these technologies as the technologies for the future, and those circulars are available on public domain. You can go through those circulars. Also, CPWD on their website, if you go, you will find the applicability of these technologies. Sometimes the question being asked that which technology to be used where. So you can find each technology, what the applicability of it, and what kind of, how many stories you can make. All those things are also available. And the idea here is to create the enabling ecosystem so that these technologies can be used in the country. Also, the entire effort which I showed you was done under Pradhan Mantri Awas Yojna. In Pradhan Mantri Awas Yojna, we are running a technology submission, and in that submission, through that submission, we are doing handholding, and we are helping state governments to make use of these technologies. So, around 1.6 million houses are being constructed across the country using these emerging technologies. Okay, and these are the states where we are working. These are the states, who have used these, most of these technologies. Okay, and this, let me just skip this. So this is the, I think again, it is from, you can see here. So in nutshell, let's replace cast in situ frame construction by these kind of things. So you can very well easily replace the frame, cast in situ frame by either light gauge or steel or a precast. Similarly, the RCC slab can be replaced by, hollow core slab, precast slabs, or a deck slab. And in a similar way, these masonry walls can be replaced by a variety of walls which I showed you. And if we look at the already these technologies are available in our country, but if just a comparison, if you see in India, still we have only 5 kiloton per annum light gauge steel use. This slide is, I think, a year back. This slide was made, might be updated, and similarly, drywall construction in India is still less than 0.5 per square meter, 0.5 meter square per capita. So that's all I wanted to tell you. And this is just that despite of all these efforts, still there are a lot of misconceptions about this new system. And as I told you that we have been creating enabling ecosystem so that these technologies become future technologies. Also, user acceptability is of primary importance. But we found that under lighthouse projects which we did, these projects were done under Pradhan Mantri Awas Yojna, where we have a center share, state share, and beneficiaries have also contributed. So almost in all the places, beneficiaries did show interest in these new technologies and did participate and did give their contribution. So if they are, if we create a proper awareness amongst the mind of users, they and build confidence, they readily accept these technologies. Also, the contractors' capacities at professional levels, we are running a course in association with the School of Planning and Architecture, where constantly we are imparting knowledge, professional knowledge, to our professionals, so that is engineers and architects, so as to create awareness, sensitize them, and build capacity, so that in future we can execute these projects. Okay, so just these few points I thought I will just share with you, and thank you. In case if you want me to ask a few questions, if Ashwin allows, then you can ask. Otherwise,
thank you, sir. Before I thank you for your wonderful presentation, I would like audience to write their questions in the chat box. If you have any questions, please write them in the chat box so that we can ask Dr. Shailesh sir those questions. Sir, it was a very wonderful presentation in terms of it is a key between what we have been doing so far in terms of SSEF, where we have been showcasing what is going on around the world in terms of the steel construction in Japan, Europe, and then US, that kind of thing that we were doing, but we were not aware of what is going on in our own country in terms of the steel construction that has been happening. So what you have shown is the new emerging technologies that are there. I mean, beyond that, structural steel is being used in PB structures a lot, pre-engineered building in warehouses, building warehouses. What you have shown today is it is encroaching into the residential part also through LGF system as well as structural steel system. I have a small doubt, sir. We give time for audience to kind of ask the questions, but is life cycle cost not part of our tender process, sir? Like, why is it not becoming a part of our tender process?
That's a good question. Let me tell the audience that Professor Ashwin was part and parcel of this journey. In fact, he has been doing the vetting of all these projects, because when we talk about innovative technologies, you have to get the design vetted. So Ashwin, I think, played a very prominent role in studying the design, particular design of all these innovative technologies, and vetting it along with other experts. A very right question. Because of paucity of time, I didn't tell you. In government sector we have a GFR, General Finance Rules, and we all are governed by that GFR, and I call it Bible. So in GFR we have introduced a chapter on contracts where we have written that if your project is of this much area, you have to consider life cycle cost. Okay, so for a project of certain size, you have to consider life cycle cost, and and that GFR came 5 or 6 years back. Okay, and I think CPWD, because of climate change, because we are talking about climate change, we are talking about net zero buildings, we are talking about less greenhouse gas emission. So the life cycle cost will become one of the important factor in times to come. So right now it is cost only, but life cycle costs will appear prominently when we tender do the tenders and other things.
Okay, sir. Okay, we have a question from Tanuja Singh, sir. She's asking, can we have cost comparison ratio of emerging versus conventional cost?
Yes. Again, if you ask this question from a professor, he will just dodge this question, but I will answer because we have done 6 lighthouse projects. In all these projects, the cost, except that project in Ranchi, where we have used modular construction, volumetric construction, the cost was 10% higher. In all other tunnel form work project which we did, the cost was 10% less than the conventional one. Number one. So if you ask me as an expert, I will tell you that there is something called threshold or critical mass. So if you are doing 100 houses or you are doing 1,000 houses, so critical mass, 1,000 houses, the cost is at par with conventional. Okay, so for each technology, there is a threshold or a limit of built up area. So if you have that much built up area, the cost will be equivalent to conventional cost. But to answer your query, the cost is 10% higher or lower, not more than that.
Okay, sir. Jayant is asking a question to you. In steel frame structure with masonry or block infill wall, how the junction is being treated. Also, how the steel frame members are covered, as normally no steel members are being seen from outside.
I think Ashwin can answer the junction thing, but steel, the major problem is of fire. So normally steel sections are to be encased. In fact, when we did this project, CPWD asked that let's encase because fire would be a problem. So I think Ashwin, you should answer this, but steel normally we encase, and junction is not a problem. Masonry wall are again infill wall. They do not take part. When we do with steel, like for sandwich panel system, we are putting a double wall. Masonry, I don't know how masonry will be connected with steel, beam and columns. But the walling system which I showed you, sandwich walling system, because it's a sandwich panel where we have a core. Core is of lighter. It's a lighter weight core of a softer material. So we put a double wall at 45-degree angle, and if it is a steel column, then we weld it at that double wall is welded at steel, flange, okay, and then inserted in the core of that sandwich panel system. But in masonry, I don't know how it is done. Ashwin, can you tell that?
Right, it is same, sir, as in case of RCC construction, where we give a zone between the underneath the beam and the junction. Right now, since we don't use masonry block in between these, we use panels.
Yes.
Precast panels are there. Those have inherent connections with the steel beam and column that are there. So those, we don't normally use red bricks for infill panel in steel construction. We use these panel systems, so that problem doesn't come there. But that system has to be any which way, it has to be anchored to the framing element. Right, sir. So Arjun CR is asking, sir, GFRG panel construction is almost 10 years old. Has this been implemented for residential construction widely in the last 10 years?
Yeah.
Whether this technology is implemented in other states than Kerala also?
Okay, so I did not show GFRG panel, but this technology was very close to my heart because this technology came from Australia. Then I, along with the professors from IIT Madras, we did a lot of research on it. A lot of PhDs were conducted, were done, and then we wanted to promote this technology because this is based on a byproduct of a fertilizer plant. We are using phosphogypsum, but unfortunately, this technology did not take off. So right now, this technology is not in use. Although it has great potential, but since we did not get access to those fertilizer plants, Okay, and they were not interested in setting up the plant to manufacture these GFRG panels. In fact, I have done 2 projects, demonstration housing projects using GFRG panel, but these panels are not being manufactured now in the country. So Kerala government also, yes, they did take interest that time, but we did have a code also on GFRG panel. But since these panels are not being, used in the country, so right now it is not being used.
Okay.
Okay.
Okay, sir. Ravi is asking, sir, for light gauge steel, how does it behave in case of fire?
That's a very good question. Yes. So light gauge you have to encase. So again, as I told you, when we are doing a light gauge wall panel, so what we are doing, we are encasing it with a fiber cement board or calcium silicate board, and that board has to have a rating, fire rating of 1.5 hours or 2 hours, depending upon the kind of building you are constructing. So if it's a residential building, then 1.5 hour rating. If it's a commercial building, then 2 or 3 hour rating. So depending upon that, you will use that kind of panel. So fiber cement board may not have that rating. So over that you will put a sandwich. Over that you will put up other panel, which will have the requisite
fire rating.
Okay.
Correct, sir.
So always, I think you have to encase these things. Okay, so in our buildings, what we are doing, we are putting a fiber cement board, and over that gypsum board is being put. From inside and outside, some other panel is being put.
Right, sir. Arjun CR is asking, for residential construction, say G+1 or G+2, which technology would be best considering durability, cost, and faster construction? And do common man have access to these contractors?
That's again a good one. If you look at my title, very smartly I've written mass construction, mass housing. So mass housing means where the same, it's a modular construction. So you have same thing repeated several times. These technologies are suitable. But light gauge is still such a thing can be used easily, and it is coming out as one of the emerging technologies. But right now, most of these technologies are for modular construction and for mass housing. Individually, even sandwich panel systems, difficult. I mean, we want that this should be used by individuals, but right now they are suitable for mass housing or modular construction.
If more contractors come in, sir, then maybe it can be.
Yes, yeah. I showed you. See, my basic purpose to show you those videos. I showed you. I will give you example. Ashwin, you will also be very pleased. 3D printing. If you, I still remember very vividly in 2019 or 18, I was approached by professors from Thapar Institute of Technology that they wanted to know about 3D printing in 2018. And believe me, I didn't know anything about 3D printing. I just searched the literature. I, talked to a few professors and all. Absolutely no idea. And today, India is. I showed you the video today. The students from IIT Roorkee, they are making printers. That time we didn't know anything about the technology. We were getting those printers from outside. Today there are more than 10 startups which are started by our own students of IITs and other institutes who are making these printers and supplying it across the world. And few of them are from IIT Roorkee. So very fast, because again, just to supplement what I said, one of the fastest growing economy, India. We are the 5th largest. We are going to become 3rd largest, $5 trillion economy. So everybody find huge potential here. So investors, startups, technology providers, they all are coming here. So right now there are contractors for light gauge. Like I gave you the example of 3D printing, light gauge. You remember Ashwin, if you might be knowing with MY1, aluminum formwork is known with the name MY1. MY1 is a Malaysian company. Right now there are more than 50 aluminum formwork manufacturers in our country. Sandwich panel system, if you recall, I don't know whether you know it or not. Earlier only HIL used to make Aerocon panels, and now there are more than 50 companies who are making sandwich panel systems of different kind. So things are moving in a positive direction, and I'm really hopeful. Like precast concrete construction, there are enough contractors now available. Aluminium formwork, I told you more than 50 companies, 50 small to large, agencies who are manufacturing those formwork system. And yes, engineers and architects, although we are trying our level best, but we need to build capacities. To embrace any technologies, we have to work on all these fronts: skill development, capacity building. It cannot happen in one day. So things are moving in right direction. I'm quite hopeful that with the passage of time, we will build up on it and make these technologies as future technologies for the country.
Thank you, sir. That ends the question answer session, sir. Things are really indeed moving positively forward. Thank you very much for this wonderful presentation, sir, making us aware of what is going on in our own country with respect to new constructions, as well as giving us data on the construction of steel, the cost of steel structures versus conventional RCC structures, and talking us about what has been done in terms of residential aspects of these emerging technologies. So thank you very much for the presentation, sir.
Thank you. Thank you. Thank you
Thank you,
for
sir.
the opportunity. Thank you.